Have you ever been watching a thunderstorm, maybe, safely inside, and you see this flash of something really weird? Not your standard lightning bolt, but this perfect glowing ball of light, almost like it's floating there, maybe even dancing a bit before, poof,
right,
gone.
Right. It's like something out of a story.
Exactly. It's in folklore. People whisper about it. You even see hints in ancient texts. But even now, with all our science, it's still just this fleeting kind of beautiful, totally baffling mystery.
Mm-hmm.
But what if? What if this ball lightning isn't just some weird weather thing? What if it holds the key to, like, the universe's biggest secrets, stuff about reality we've just totally missed?
Yeah, maybe even a source of unlimited energy. That's the really wild part.
Right.
It's a huge question. And honestly, ball lightning is one of those things that's just persistent. Frustrating for scientists, almost embarrassing,
How so?
Well, think about it. We've sent probes, like way out past Pluto. We build these massive colliders miles long to smash tiny particles together. We've mapped the human genome.
Yeah, we've done incredible stuff, peered into black holes, seen the afterglow of the Big Bang.
Exactly. All that micro-world, macro-universe stuff. Yet this thing, this glowing ball that sometimes literally appears in people's houses, maybe from a dodgy plug socket, we still barely understand it. It's just there, visible, but it doesn't fit.
It's like a little glowing cosmic riddle just hanging there, laughing at us.
Pretty much. And that's exactly what we're diving into today. We've got this stack of material, really dense but fascinating stuff, from a researcher who says they've done way more than just watch ball lightning.
Okay, what are they claiming?
They claim they've figured out what it is, its real nature. And not just that, they say they've actually, tamed its power.
Tamed it, controlled it.
That's the claim. So our mission today, dig through all this, pull out the biggest ideas, the most surprising bits, and hopefully leave you with some mind-bending facts, a sense of the sheer scale of this thing, and maybe, just maybe, a totally new way of looking at reality.
Okay, I'm ready. Let's get our brains flipped. The enigma of ball lightning. More than just a pretty light show. All right, let's start at the beginning then. If this thing is so weird, so visible, and people have been seeing it for ages, why hasn't it been, a huge focus for physicists? Why isn't it front page science news all the time?
That's a really good question.
Yeah.
And the sources we looked at point to a few key reasons why mainstream science has been kind of skeptical, or at least hasn't poured massive resources into it.
Okay, like what?
Well, first, there's been this general feeling, maybe understandable, that even if we figured it out, what's the big payoff? The common thought was its energy is probably tiny, maybe just leftover charge from the storm or something.
So not worth the effort, basically. A curiosity.
Oh, pretty much. Why spend millions researching something that might just be, atmospheric static electricity doing something funny?
Right.
It didn't seem like it would lead to, say, new energy sources or fundamental breakthroughs.
Right. What else?
The second big one is reproducibility. Science thrives on experiments you can repeat, right? Test theories.
Of course.
But natural ball lightning, it pops up randomly.
Yeah.
It's inconsistent, hard to study in a lab if you can't reliably make it happen on demand. And without understanding what it is, how do you even start trying to make it?
So mostly just eyewitness accounts, anecdotes.
A lot of it, yeah. Which makes rigorous science really difficult. You need more than just stories. You need a framework, a theory to test.
Okay, that makes sense from a practical science point of view. But our author, they obviously disagree.
Oh, completely. And they point to others who felt the same way, even decades ago.
Yeah.
They mentioned this 1989 symposium report on ball lightning from Waseda University in Tokyo.
What did it say?
Get this. It called ball lightning a phenomenon of qualitatively new character, similar to radioactivity, which may turn out to be a new, precious source of energy in the future.
Wow. Comparing it to radioactivity, that's huge.
Exactly. Not some minor quirk. They saw it as potentially revolutionary. The report suggested the most common view even then was that it's a new and unknown form of stable plasma or ionized gas.
Stable plasma, not just a flash in the pan.
Right. And here's the kicker, the part that really fuels our author's work. The report said if research advanced, the results may turn out to be quite surprising and determine an unexpected turn in future energy production. They called the field new. Unprecedented, fantastic.
Fantastic. Okay, so that's a world away from negligible energy, not worth studying. It sounds like they suspected something really big was hidden there.
Definitely. And our author, they didn't just suspect it, they make this incredibly bold claim. After years and years of experiments, apparently self-funded, grinding away, they say they finally tamed quantum-free energy right at the end of the 90s.
Tamed quantum-free energy. What does that even mean?
It means they claim they understood its unusual quantum nature and figured out how to excite it, how to make it produce abundant free quantum energy.
So not just understanding it, but using it, controlling it.
That's the claim. A claim of mastering this bizarre phenomenon.
Okay. Before we get into how they claim to have done that, let's talk about the raw power. You mentioned radioactivity. What kind of power are we actually talking about with natural ball lightning? The sources must have some examples, right?
Oh, absolutely. The author details some really astonishing incidents, drawing heavily from work by a respected Russian professor, Boris Smirnov. Smirnov documented some incredible cases.
Like what? Give me the highlights.
Okay, picture this. A football-sized fireball bouncing down a street. Not rolling, bouncing. And it left behind this perfectly round channel in the asphalt, like it just carved its way through.
Bouncing! That's really weird, like a rubber ball made of light.
Kind of. Then there's this incident in Khabarovsk, Russia. Ball lightning apparently fell into a reservoir, 7,000 liters of water.
Okay.
It boiled all of it. 7,000 liters in 10 seconds.
Wait, what? 10 seconds? That's impossible, the amount of energy.
Exactly. And then after boiling the water, it exploded, with force equivalent to 2 tons of TNT.
Oh, tons from a ball of light. Okay, my brain is starting to flip already.
Right. And it gets darker. Another account. A tennis ball-sized one fell into some mountaineer sleeping bags. Killed one person, severely burned others. And in some cases, the reports say it tore flesh right down to the bone.
Jeez. That's not just heat. That sounds like some kind of focused energy beam or something. Incredibly violent.
It does. And there are lots of reports of ball lightning melting metal, sometimes evaporating grams of it instantly. And one case that really stands out, it passed through a 5-millimeter thick pane of glass.
Through it, like a ghost.
Not quite. It left a hole, a perfectly clean, precise hole. Witnesses said it looked like it was cut by a laser.
A laser hole? Through glass?
Yeah. Suggesting, as the author puts it, an extraordinarily concentrated force. Not just diffuse energy, but something focused, powerful.
Extraordinarily concentrated force. Okay. That changes things. It's not just a pretty light. And you mentioned ancient texts. Our author thinks this isn't new, that this force has been around, maybe messing with history.
That's exactly their argument. They connect these modern accounts to ancient mysteries, suggesting people saw the same thing thousands of years ago, but described it differently.
How far back?
They point to the destruction of Mohenjo-Daro, that ancient city in Pakistan, 4,000 years ago. Archaeological evidence suggests intense heat-melted stone in the city. The author links this to accounts of a glowing ball with blinding light appearing over the city.
Melting stone from the sky.
That's the idea, not a normal fire. And they don't stop there. They suggest maybe the fiery chariots of the Greeks and Romans.
Like in the myths.
Yeah, or Elijah's fiery chariots in the Bible. American Indian stories of round baskets of light.
Yeah.
Japanese tales of celestial phantom ships with glowing lanterns.
Round baskets of light. That sounds suspiciously like ball lightning.
Doesn't it? And even the destruction of Sodom and Gomorrah, fire raining from heaven. The author suggests maybe, just maybe, these weren't metaphors or divine acts in the way we usually think. Maybe they were witnessing this incredibly powerful natural phenomenon.
So ball lightning as the explanation for ancient miracles and disasters, that's a massive claim. 2, mind-blowing scale. From tiny orbs to cosmic events. Okay, this is getting wilder and wilder. Boiling reservoirs, melting cities. The scale is already huge. But here's where my mind really starts buzzing. If it can do all that, what about Tunguska?
The Tunguska event. Yeah, that's the ultimate mysterious kaboom, isn't it?
Yeah.
1908, remote Siberia, massive explosion, flattened forest over hundreds of square miles, but no crater.
Exactly. Theories range from meteorites to comets to mini black holes, even antimatter.
Right. It's been over a century, and still no definitive answer. They put forward a very detailed case that Tunguska was, wait for it, exceptionally large ball lightning.
Exceptionally large? How large are we talking?
The estimates based on the blast pattern suggest the bright ball itself was around 400 meters in diameter, almost half a kilometer across.
Half a kilometer? Okay, that's not a tennis ball in a sleeping bag. That's immense. But how do they argue against the standard theories? Meteorite seems plausible, right?
Plausible, but problematic. The author goes through it systematically. First, the nuclear explosion idea. Some people suggested that. But studies of the soil, the gases, the minerals, absolutely zero sign of increased neutron counts or the specific isotopes you'd expect from a nuclear blast. So, scratch that.
Okay, no nuke. What about the meteorite?
That's the most common one. But despite decades of searching that vast area, not a single metallic fragment, no meteorite debris, has ever been found. And crucially, no impact crater. A rock big enough to cause that much devastation should have left something.
Right. It just vanished.
Seems like it. Then there's the comet theory. Maybe a chunk of dirty ice?
That would explain the lack of rock fragments, maybe?
It could, but comets entering the atmosphere heat up intensely. An icy comet that size should have produced a massive, visible cloud of gas and water vapor as it burned up and evaporated.
And did it?
Nope. Eyewitnesses reported the bright object, the explosion, the shock wave, but no giant cloud. In fact, the sky near the event was reportedly clear, even though there were weird atmospheric effects seen across Europe for days afterwards, strange glowing skies at night.
So the conventional explanations just don't quite fit all the facts. Okay, so how does the ball lightning theory hold up? Don't you usually need a thunderstorm for ball lightning? Was there a giant storm over Tunguska?
That's a key point the author addresses. While storms help, they argue the crucial factor is full ionization of gases in a certain volume. Basically, the air needs to be electrically charged up.
And was it in 1908 Siberia?
Apparently, yes. Conditions were incredibly favorable. 1908 was near the peak of not just the regular 11-year solar cycle, but also a longer, more intense secular cycle of solar activity.
So the sun was extra active.
Extremely active. Increased solar flares, big sunspots, bright corona, lots of radio emission. And this solar activity directly impacts Earth's atmosphere.
How?
It caused intense geomagnetic activity. Earth's magnetic field was disturbed, and people observed all sorts of weird optical stuff. Strange high-altitude clouds called noctilucent clouds, bright auroras seen much further south than usual, odd atmospheric light polarization, and this weirdly bright night sky that peaked on the day of the Tunguska event.
Wow, so the whole atmosphere was kind of fizzing with energy.
That's a good way to put it. Very favorable conditions for ionizing a huge volume of gas, creating the potential for a massive ball lightning event far beyond a typical thunderstorm.
Okay, the conditions were right. What other evidence supports the ball lightning idea for Tunguska?
Several things. One is maneuverability. Eyewitness accounts suggest that Tunguska object's path wasn't a straight ballistic fall like a rock. It showed some deviations.
It changed course.
Apparently, which a meteorite or comet absolutely cannot do. But ball lightning, being an electromagnetic phenomenon, can be influenced by Earth's gravitational and electromagnetic fields. It can maneuver. And significantly, magnetic disturbances were recorded in Irkutsk, relatively nearby, right after the explosion.
Consistent with an electromagnetic event. What else?
Well, ball lightning is theorized as a kind of spherical capacitor carrying a big electromagnetic charge. Soil studies in the Tunguska area found remagnetization. The magnetic properties of the soil were altered. That fits perfectly with a powerful electromagnetic pulse you'd expect from a giant ball lightning discharge.
Okay, magnetic evidence too. Interesting.
Then there's the decay pattern. Smaller ball lightning often breaks up into even smaller spheres before they finally pop.
Right.
Eyewitnesses at Tunguska reported multiple explosions and simultaneous fires, starting in different widely separated areas of the forest. That matches the pattern of a large ball lightning breaking apart as it discharged its energy. Not just a big impact point.
Distributed destruction. Okay.
And maybe the weirdest bit, the mutated trees and ants. There were genetic mutations found in plants and insects all along the trajectory of the object, not just at the blast site.
Mutations, like radiation.
Exactly. The standard comet theory suggested maybe UV radiation from a damaged ozone layer, but our author points out ball lightning naturally emits UV. And crucially, the mutations affected trees grown from seeds buried deep in the soil. UV doesn't penetrate that deep.
So UV isn't enough?
Probably not. The author argues that Tunguska ball lightning must have been excited maybe by interacting with Earth's magnetic field or atmospheric currents, causing it to emit more penetrating radiation, like X-rays or even gamma rays, which could reach those deep seeds.
Okay, that's complex, but it ties things together. What about the sheer energy? Could ball lightning really produce that much power?
That's the final point. Conventional impact theories struggle to explain the sheer magnitude of the blast and the specific damage patterns. The author's calculations, based on their QML model, show how a large ball lightning could accumulate immense energy very quickly and then release it in a monstrous explosion.
How monstrous?
The energy equivalent was estimated at about 2,000 times the power of the Hiroshima atomic bomb.
2,000 Hiroshima bombs, just wow. So if this author is right, Tunguska wasn't an alien spaceship or a black hole. It was just nature, but on a scale and operating under physics we barely comprehend. A giant, supercharged ball lightning.
That's the argument. A century-old mystery potentially solved by understanding this phenomenon, powered by physics beyond our standard models. It completely reframes it.
Hey, just jumping in here, if you're finding this deep dive as absolutely mind-bending as we are, and you're loving connecting these cosmic dots with us, do us a huge favor. Go ahead and like this deep dive, smash that subscribe button, and hey, if you really want to support our mission of uncovering these incredible hidden truths and keep us digging into the weirdest corners of science, definitely join our memberships. It genuinely helps us keep bringing you these deep dives into the most fascinating topics out there. All right, now back to making your brain do flips.
Okay, so Tunguska might have been a colossal ball lightning event, 2,000 Hiroshimas. That scale is already hard to grasp. But our author doesn't stop there, do they? They connect this phenomenon to stuff happening even higher up in our atmosphere and even way out in deep space.
No, they definitely keep expanding the scale. It's like they see this principle operating everywhere. Take the auroras, the northern and southern lights.
The author proposes they're essentially natural accelerators of quantum-free energy. Their idea is that up high, where the atmosphere is thin and solar radiation hits hard, the conditions are right for gigantic ball lightning to form in those polar regions.
Giant ball lightning in the upper atmosphere.
Yeah. And when charged particles from the sun stream in the solar wind, they pass through the electron shell of this giant ball lightning. The author claims this interaction significantly accelerates those solar particles.
Like a natural particle accelerator.
Exactly. These super sped up particles then slam into the lower atmosphere, ionizing the gases, knocking electrons off atoms, which makes those atoms glow in those characteristic colors: violet, red, green.
So the aurora isn't just particles hitting air, it's particles being boosted by giant atmospheric ball lightning first.
A planetary-scale quantum energy phenomenon lighting up the sky. Okay, that's a new take on the Northern Lights. But they go even bigger, right? Neutron stars.
They do. This is probably the most audacious claim in the whole theory. Neutron stars.
Remind us, super dense, city-sized remnants of dead stars. That's the standard picture. Incredibly dense, maybe twice the mass of our sun crushed into something 10 kilometers across, like a giant atomic nucleus.
So what's the author's spin?
They argue that neutron stars are gigantic cosmic atomic nuclei the size of a city. Yes. But fundamentally, they're a gigantic cosmic ball lightning.
A neutron star is ball lightning.
On a cosmic scale, yes. They reject the idea that neutron stars are just the dead cinders left after a supernova. Instead, they say the gigantic explosion happens as a result of gigantic cosmic ball lightning. The star itself is the phenomenon.
Okay. That's a radical departure from standard astrophysics.
Totally. And they point out that while we often detect them as pulsars emitting radio waves, their main energy output is actually in X-rays and gamma rays, very high-energy photons, which fits their model of excited quantum energy release.
And the power involved.
Get this. The author calculates that the explosion of one of these cosmic ball lightning neutron stars could release energy equivalent to the total photon radiation of the entire galaxy.
A whole galaxy all at once. That's unthinkable power.
It is. And they connect this to another cosmic puzzle. Gamma ray bursts. These incredibly intense, brief flashes of gamma rays, sometimes packing the energy the sun produces over its entire lifetime into just seconds.
Yeah, those are bizarre. Where did they come from?
The author proposes they are giant cosmic gamma ray guns, originating from these neutron stars, these giant cosmic ball lightnings, firing beams of pure energy across the universe. So it connects tiny earthbound orbs, the Tunguska explosion, the auroras, and the most energetic events of the cosmos into one single underlying phenomenon. 3. Unpacking the quantum macro object, QMO, the core theory.
Wow. Okay. From a zap in the house to neutron stars firing gamma rays across the galaxy. If ball lightning or this QMO thing can explain all that, what exactly is it? What's the core theory? It sounds like they had to invent some completely new physics.
They pretty much did. This is where we get into the author's theoretical model developed back in '95, which they claim led them to actually mastering quantum energy. And it all hinges on a completely different understanding of reality itself, specifically around energy.
Okay, break it down for us. ELI 5, if you can.
All right, I'll try. The core idea is, imagine there are quantum boundaries of the world, like two different zones of reality.
Zone 1 and Zone 2.
Kind of. Inside these boundaries is our normal world. Stuff is predictable. Objects have 3 dimensions: length, width, height. And all the physics we know, gravity, electromagnetism, crucially the law of conservation of energy, they all work perfectly. Energy isn't created or destroyed, just changed. That's Zone 1, our zone.
Okay, familiar territory. What about Zone 2? outside the boundary.
That's where things get really weird. Outside this boundary, the author says, the normal laws break down. They're replaced by the rules of the boundary itself. And here's the mind blower. Three-dimensional objects are replaced by two-dimensional quantum units.
Two-dimensional, like flat.
Fundamentally flat, yes. And crucially, the author claims outside this zone, the law of conservation of energy is violated.
Violated. Broken. You mean energy can be created or destroyed there?
That's exactly what they're saying. It's a zone where energy can apparently appear from, well, not nowhere, but from the quantum nature of the boundary itself. And they argue modern science doesn't even suspect this zone or these 2D objects exist because we're stuck thinking only about Zone 1 physics.
Okay. My brain is officially buzzing again. So how does ball lightning fit into this? How does it cross the boundary?
The theory goes, if you ionize a gas, like air, really, really fast, and completely strip off all the electrons and the leftover atomic nuclei, the protons and neutrons, can get pushed outside this boundary into Zone 2.
Push into the 2D zone.
Yeah. And in that state, the collection of nuclei becomes a single structureless quantum unit. The individual atoms lose their identity and merge into one quantum thing. But the electrons, they stay behind, forming a normal cloud of free electrons around this weird 2D nucleus.
So a 2D quantum core surrounded by a 3D electron cloud.
Exactly. And that whole structure, the 2D nucleus plus the 3D electron cloud, is the quantum macro object, the QMO.
Yeah.
That's what ball lightning is, according to this theory.
And this 2D nucleus, it's just a surface, no inside.
Precisely. The author says a quantum object like this can only be a closed two-dimensional formation. It's open outwards, meaning it just is a boundary. They call this boundary surface alpha. It separates the 2D quantum nucleus from the surrounding space and the electron cloud. The space enclosed by the surface isn't part of the object. It's just empty space trapped within the 2D shell.
Okay, that's incredibly abstract. A 2D object, outside normal physics, violates energy conservation. How on earth did the author claim to prove this experimentally? That sounds impossible to demonstrate.
It does sound impossible, but they describe specific experiments they say confirmed it. For instance, they tried poking ball lightning with a metal rod.
Did it go through?
Nope. The rod just couldn't penetrate. It was like hitting an invisible solid wall, but not solid like a normal object. The author says it's because there is no inside of the ball lightning. It only deformed the surface slightly, like denting a bubble, but the surface itself remained intact and always bounced back to its original size.
So it acts solid, but only as a surface.
Yeah. And that, they argue, explains why air currents can push it around easily. It's like a hollow shell. And why gas molecules trapped inside can leak out easily. They aren't really in anything.
What else? Any other weird behavior?
They noticed radio waves of similar wavelengths get messed up near it, causing static. Like the waves are bouncing off this invisible barrier. And crucially, they found it's impermeable to electrical current.
Impermeable. Current can't go through it.
Right. When they applied a high-voltage, low-amperage current, it didn't flow through the ball lightning. Instead, the electrical arc literally wrapped around the surface. It enfolds the ball lightning nucleus, preferring to slide along the outside rather than penetrate.
Like water flowing around a rock.
Exactly. As if the current itself recognized there was no inside pass to take. For the author, this was direct, visible proof of its 2D, surface-only nature.
Okay. Poking it, zapping it. That's compelling, if true. So what's the final conclusion from all this experimental work?
The author declares, based on this evidence, that ball lightning is fundamentally a giant macro atom. It has a two-dimensional quantum nucleus, that surface alpha, and a three-dimensional electron cloud.
A giant macro atom.
Yeah. And they state this discovery changes the field of physics in a fundamental way, putting it on par with Newton discovering classical mechanics. It's a claim to have found a whole new layer of physical reality.
That's staggering ambition. A new Newton. So if it's this giant macro atom, what about its electrical power? We talked about boiling water in Tunguska. Does the theory quantify that?
It tries to. The author admits their initial calculations might not be perfectly precise, but their model points to unusual electrical characteristics and huge energy possibilities. They estimate the electron cloud is about 3 to 10 millimeters thick, which matches their lab observations.
Okay, but the energy.
This is where it gets really mind-boggling. Their calculations suggest the electrostatic field around this 2D QMO nucleus can become very strong. How strong? They compare it to CERN's Large Hadron Collider, the most powerful particle accelerator on Earth, which reaches energies of about 7,000 giga-electron volts, GeV.
Right, which is already immense energy.
The author's QMO calculations suggest potential energy levels 70,000 times higher than CERN.
70,000 times CERN. In potentially a small ball of light, that's almost comical levels of energy density.
It sounds utterly unbelievable, but they point to evidence they say backs it up, like their experiments where metallic sticks were rapidly destroyed, not melted, but seemingly eroded away at an atomic level by fast electrons from the ball lightning.
Like sandblasting with electrons.
Kind of. And remember the natural case of ball lightning punching that clean hole through glass without melting it?
Yeah.
That suggests focused non-thermal energy.
Right, the laser beam hole.
Yeah. Plus, the fact that ball lightning can injure or kill in a way similar to a very strong electric field, not just heat burns, and its ability to disrupt nearby electrical systems.
Mm-hmm.
Even in their lab, they saw tiny ball lightning destroy sturdy electrodes in seconds, punching holes without melting, again pointing to very high energy electrons. It's a different kind of energy interaction. 40. Harnessing the impossible. Free quantum energy.
Okay, so we have this giant macro atom, this QMO, with potentially insane energy levels, existing in a 2D state where energy conservation might not apply. How do you actually get that energy out? How do you tap into this free energy? What's the mechanism for violating that fundamental law?
This is the absolute core of the author's claim, the how-to for harnessing the impossible. They state directly, free energy comes from violating the law of conservation of energy in specific quantum states.
How can you just violate it? Isn't that like violating gravity?
The author has a philosophical take on this. They say, okay, there's the constitution of the world, the really deep rules, quantum constant, symmetries, those are untouchable. But specific laws, like energy conservation, they argue there are no principal obstacles to violating that law under special quantum conditions.
So it's not always absolute. It can be bent.
In specific circumstances, yes. They argue energy itself, when not tied to matter, doesn't have an individual face. It's just a potential. So if the deeper quantum rules conflict with energy conservation in these extreme QMO states, then Mother Nature can sacrifice this fundamental physical law. It's like the universe takes the path of least resistance, even if it means bending a law we thought was unbreakable.
A cosmic loophole.
Right.
Okay, so how do you exploit this loophole? How does the energy extraction actually work in their experiments?
It comes back to zapping the ball lightning. When they apply that electrical current, remember how it slides around the impermeable 2D nucleus in the electron shell?
Yeah, the water around a rock thing.
Right. As those electrons are forced to zip around the nucleus, they radiate energy photons. It's called synchrotron radiation, like in a particle accelerator.
Okay, but that usually takes energy, doesn't it?
Normally, yes. But here's the twist. Initially, according to what the author calls the principle of economy, only the free electrons, the ones just floating around, not strongly bound to the QMO nucleus, carry the current. That minimizes the weird quantum effects.
Okay.
But if you crank up the current, make it stronger, then the low energy levels quantum electrons, the ones actually bound to that 2D nucleus, start getting involved. And that's when the ball lightning starts to shine really intensely.
Because the bound electrons are releasing energy.
Yes, but here's the really weird part. The author claims these quantum electrons can only emit their entire quantum energy at once. It's all or nothing. They can't just release a little bit.
All or nothing.
So if you apply a really strong excitation current, you can force electrons from the inner layers of the QMO's electron shell electrons with extremely high energy to participate. When these electrons release their entire massive quantum energy payload, they don't just emit visible light. They emit X-rays, gamma rays, maybe even more exotic stuff.
And that's the free energy. The energy coming from those bound quantum electrons being forced to dump their entire load.
That's the quantum free energy radiation, exactly. It's an amplification process where the output energy, particularly at high excitation levels, vastly exceeds the input electrical energy used to stimulate it. More comes out than you put in.
Wow. They even have a name for a device based on this, right? A quasar?
Yeah, like a laser. Light amplification by stimulated emission of radiation, but a quasar. Quantum amplification by stimulated emission of radiation. They envision using ball lightning to create focused beams of gamma photons. Basically, a gamma ray laser.
A gamma ray laser powered by free energy. So it's not just power generation, it's potentially revolutionary tools for physics too. But they take it even further, don't they? Something about antimatter and mirror worlds.
This bit is really out there. They look at that quantum surface alpha, the 2D boundary of the nucleus, and propose it acts like a mirror. A mirror reflecting an anti-world containing antimatter like positrons, anti-electrons.
In actual anti-reality, not just theoretical.
They would claim it's a real and actual anti-reality, accessible or observable through the QMO, like the ball lightning is a window or portal into this antimatter dimension.
Okay, portal to an antimatter dimension. My brain needs a reset. So, summing up the potential impact here.
Yep.
Huge, right?
If any of this is real, the impact is almost unimaginable. Three main things. One, unlimited, safe, cheap energy. Game over for energy poverty. Two, practical, super powerful particle accelerators, way beyond CERN, unlocking new physics. Three, direct rocket propulsion photon rockets making interstellar travel potentially feasible. It changes everything.
Yeah. Number 5, the technology and future, world-changing applications and terrifying dangers.
It really does sound like science fiction made real. Limitless energy, new physics, photon rockets, and the author claims they worked on this for 18 years, built hundreds of designs. Did they actually build something that demonstrates this free energy? Is there proof beyond the theory?
They claim they did, yes, and they described the experimental setup in quite some detail, emphasizing how simple and relatively cheap it was, around $5,000 they estimate for the core QE research setup.
$5,000. For potentially world-changing physics, what did it involve? Pretty standard lab gear, actually. An industrial microwave oven, like a really beefy kitchen one, about 2,200 watts. A small spherical quartz container, maybe 4 inches across. Some tungsten electrodes. A vacuum pump. Basic thermometer. A calorimeter to measure energy output accurately. And an electron gun.
Okay, seems almost mundane for discovering free energy. How did they use it? What's the procedure?
Simple enough. Create a vacuum in the quartz sphere. Turn on the microwave that makes a plasma, then slowly let gas back in. As the pressure rises, the ball lightning appears, getting brighter as pressure increases, up to normal atmospheric pressure. Then zap it with the electron gun, injects more electrons, makes it brighter and more stable.
And then the magic happened.
Then comes the excitation current. They applied about 1,500 volts at 10 amps across the electrodes, touching the ball lightning. And that's when it apparently became extremely bright. Shining, they say, like a 12 kW bulb, blindingly bright from this little sphere.
Okay, bright is one thing. What about the energy? Did they measure more out than in?
This is the crucial claim. They noticed something weird. The ball lightning offered almost zero electrical resistance. So even though they applied 1,500 V, the actual voltage across it dropped to only about 100 V.
Meaning the actual power going in from the excitation current was much lower.
It's only about 400 watts, 100 V by 10A, roughly. Ignoring some complexities.
Yeah.
So total input, 2,200 W from the microwave plus 400 W excitation equals 2,600 watts.
Okay. And the output?
Measured carefully with the calorimeter, they claim the output heat plus the light radiation was around 2,800 watts.
2,800 out, 2,600 in. That's more out than in?
Yep. Do the math. 2,800, 2,600, 108% efficiency. The author calls it a small but very reliable free energy effect. More energy came out than they put in to excite it.
108%. That's over unity. That's the proof, if it's real. But okay, 108% is interesting, but not world-changing power levels yet. How do you scale it up? How do you get from 108% to powering a city?
The author gives specific instructions for getting a very powerful QE effect. 3 key factors. First, input microwave power. They say QE output goes up exponentially with input power. Put in over 100 kW, they claim, and the output can be hundreds of times greater. So you need big generators to get big returns. Small ones aren't economical.
Exponential growth. Okay, that's promising for scaling. What else?
Second, working gas pressure. The QE happens in the electron cloud. Denser gas means more particles in that cloud to interact with the nucleus and transfer energy. They expect hundreds of times more QE output at normal atmospheric pressure compared to low pressure. And interestingly, they found oxygen and air work best, not hydrogen or helium.
So you can run it in normal air? That's a huge engineering advantage?
Seems so. And third, additional electrons. Injecting extra electrons into the shell, maybe with a bigger electron gun, significantly boosts efficiency many, many times, they say. The QMO doesn't care if the electrons are native or added. They all help transfer energy.
More input power, denser air, more electrons equals potentially massive free energy.
That's the recipe, leading the author to call ball lightning an inexhaustible source of free electrical energy. They describe the QMO as a QE spherical electrical capacitor. But unlike a normal capacitor that just stores and discharges, this is a quantum battery that generates energy continuously from that quantum loophole. Unlimited power.
Mind blown again. Okay, beyond just limitless electricity, what other applications did they foresee? You mentioned accelerators.
Right. Two huge ones, extremely bright X-ray sources. Current synchrotrons cost hundreds of millions, even billions, and are huge. QE generators, they claim, could be small, room-sized, maybe $500,000, and produce much brighter X-rays.
What we use those for?
Revolutionizing stuff.
Yeah.
Making much smaller computer chips, nanotechnology. Developing new drugs by understanding microbiology better. Figuring out exactly how proteins work at super fast speeds. Understanding corrosion and catalysis. It's a fundamental tool for material science and biology.
Okay, huge impact there. And the accelerators?
Same deal. Current ones, like CERN, cost billions and are city-sized, reaching maybe 1 GeV for electrons, QE colliders. Right. Maybe room-sized again, $500,000, but generating monstrous energy, potentially 30,000 to 100,000 GeV.
Orders of magnitude higher, what could that do?
Discover entirely new elementary particles, probe physics way beyond the standard model. It would be like getting a new set of eyes to see the fundamental structure of the universe. A total game changer for physics.
Okay, this sounds like paradise. Limitless clean energy, metal breakthroughs, understanding the universe. It feels too good to be true. What's the catch? There has to be a dark side to unlocking this kind of power, right?
Oh, yes. The author is very clear and very worried about the dark side. The gravest application, the quantum photon bomb.
Oh, boy. How bad are we talking?
They estimate QFE, weaponized, could be millions or billions of times more powerful than nuclear energy. Just let that sink in. Millions or billions.
That's extinction-level power.
Easily. But the truly terrifying part, according to the author, how easy it might be to make. They claim QFE weapon programs are very cheap, could be done in garage conditions, and do not need super qualified specialists.
Cheap, easy, garage-built bombs millions of times stronger than nukes. That's the ultimate nightmare scenario.
It really is. It completely bypasses the massive industrial and scientific hurdles of nuclear weapons. The author is deeply concerned about proliferation. How can you prevent China? How can you prevent other countries? How can you prevent terrorists? They specifically mention the U.S. and Israel as vulnerable.
Because anyone could potentially build one.
That's the fear. They make this passionate plea saying it's maybe impossible to avoid this weapon in a world driven by money and power politics. They call for governments to actively prevent it and remove the political reasons for wanting such weapons.
It sounds like they see it as an almost inevitable threat.
They do. They list it alongside other end-of-day scenarios like asteroids, but they add the Frankenstein effect.
Frankenstein effect.
Yeah, where our technology, our power, outraces our wisdom and control, unleashing something like QFE before we're ready, before we have the global mechanisms to manage it safely.
A monster we can't control.
Exactly. And then, in a really startling move, the author makes this offer. Basically saying they're ready to work specifically for the U.S. government for $3 million and about 18 months with a small team.
To do what?
To build the first 800 kVU peaceful QFE generator, and also a small power, more than ordinary nuclear bomb, quantum photonic bomb.
Wait, build the bomb too? Why?
Their stated rationale seems to be, get the technology under control, understand it, perhaps develop defenses before others do. They call it a QFE Manhattan project, but much cheaper and much more effective. It's a really unsettling offer, highlighting the dual use potential.
Yeah, that's deeply uncomfortable, showing you can build the ultimate weapon as part of the deal.
And just to ground this a little, they briefly mentioned Russia's known research into microwave plasma weapons back in the 90s, weapons designed to take out missiles using plasmoids. So the idea of weaponizing this kind of energy isn't purely theoretical. Major powers have explored related concepts. It makes the author's warning feel less like science fiction and more like a potential near-future reality. Outro.
Wow.
Okay.
This deep dive, it's been one heck of a journey. We went from these weird little glowing balls people see sometimes, all the way to the destruction of ancient cities, the Tunguska explosion, the northern lights, neutron stars, the very laws of physics, unlimited energy, and potentially planet-ending weapons built in a garage. It's completely mind-bending.
It really is. If the author's core ideas are even partially correct, that ball lightning is this quantum macro object, this 2D entity living outside our normal rules, demonstrating that energy conservation can be violated. The implications are just staggering. Quantum-free energy changes literally everything.
It forces you to ask some huge questions, doesn't it?
Absolutely. What happens if the fundamental laws we've built our entire understanding of the universe on turn out to have these quantum loopholes? What do we do with that knowledge?
And more urgently, if this kind of power-free energy super weapons is actually achievable, how on earth do we make sure it's used for creation, for solving problems, and not for well, for destruction on an unimaginable scale.
It might be the single most important question humanity could face this century. The stakes are almost too high to contemplate.
Powerful thoughts to end on. Definitely something for all of us to chew on. Keep questioning, keep exploring the boundaries of what we think is possible, and definitely keep driving deep with us. Until next time, stay curious.